Hello, this is Bakersfield College Industrial Automation, and I'm Chad Hidalgo. For INDA B120, Industrial Automation System Robotic, Professor Manuel Fernandez, final presentation. Industrial robots versus collaborative robots, or cobots. A comparison of Fanuc LR-Mate 200ID 4S and Universal Robots UR5. First of all, what is a robot? The word robot was first used by Karel Čapek in a 1921 play called Rossum's Universal Robots. It is taken from the Czech word robota, meaning drudgery. The Oxford English Dictionary Online defines robot as a machine capable of carrying out a complex series of actions automatically, especially one programmable by a computer. How are robots helpful to humans? The 4 Ds are types of jobs that robots can assist humans with and sometimes even replace them. Dull. Jobs that are repetitive and lacking in intellectual stimulation have been shown to cause apathy at work and lead to poor job performance, frequent turnover, and in the worst cases, serious job-related injuries. Robots can easily be programmed and fitted with the proper tooling to carry out those dull jobs. Dirty. Jobs that are very dirty are undesirable by most humans, and robots can be hardened to perform in dirty jobs, and especially jobs that are potentially infectious to humans, such as sewer sanitation. Dangerous. Jobs that are very dangerous account for the loss of human life every year. Fortunately, robots can be programmed to perform in dangerous situations, and in the worst case scenario, a robot can easily be replaced without the irreparable harm caused when a workplace death occurs. Difficult. Jobs that are not easily performed by humans because of manual dexterity or awkward positioning are simplified by robot applications. Jeff Christensen, Vice President of Products with Sigrid, in an article for Material Handling and Logistics writes, "Some low-wage, non-value-added jobs can be replaced by automation, and this raises concerns that robots are stealing jobs, but some jobs should be automated. The highly repetitive, dirty, dangerous tasks we once asked humans to fulfill can now be completed by robots, which are both safer and more efficient. This shift in responsibility frees up human employees to fill new roles more suited to their talents. Humans have the capacity for creativity and decision-making to contribute at higher levels, while their robot colleagues bear the heavy loads." Industrial robots come in a wide variety of shapes, sizes, payload capacities, and available end-of-arm tooling. Industrial robots are typically larger than collaborative robots or cobots and can handle far greater payloads. Cobots are generally slower than industrial robots and are designed to detect human beings within their work envelope, which causes them to slow down operation or stop until the person is safe from potential harm. Industrial robots are typically isolated from human beings by safety cages because the work they perform and the speeds and forces with which they operate can cause serious injury and even death. The work envelope is the space that the robot operates in, and industrial robots are normally surrounded by a safety cage. This is an example where the operator is enclosed in a safety cage because the work envelope of the robot is so large. OSHA requires that any personnel entering a robot work envelope carry the Teach pendant. This is the Teach pendant. It's a user interface that enables the programmer to talk to the robot controller. The important features of the Teach pendant and the robot controller are safety features such as an emergency stop and a 2-position dead man switch. The switch is designed in such a way that if the operator releases the switch, all of the robot's motion will stop. Or if the robot should strike the operator and the operator squeeze too hard on the switch, the robot's operation will also stop. The cost of the Fanuc LR-Mate is approximately $28,925. According to Tony DeLigio and Matt Nitove, writing for Plastics Technology Online, ptonline.com, Germany's Institute for Occupational Safety and Health, the IFA, defines the new category thusly. Collaborative industrial robots are complex machines which work hand in hand with human beings. In a shared work process, they support and relieve the human operator. Cobots are not intended to take people's jobs, but rather to support them and increase their productivity. The Rodon Group was an early adopter of the Baxter collaborative robot. Safety is the biggest advantage Rodon sees in collaborative robots. Full servo robots are fast and accurate, but you sure don't want to get in their way when they're moving, says Allen. Baxter's low speed and collision sensitivity alleviate that risk. Collaborative robots such as the UR5 from Universal Robots cost approximately $25,600. This is an example of the teach pendant for the UR5. Called the Polyscope, it looks and acts very much like a tablet, a PC tablet, Android or iPad. And it also includes the e-stop and the power button. Contrasting industrial robots and cobots. Industrial robots rely upon a safety cage either for enclosing the robot or enclosing the operator. Cobots are designed with proximity sensors and vision systems to protect their human operators. Industrial robots are designed with heavy payload and high-speed considerations, whereas cobots usually have a reduced payload and slower speeds. Industrial robots are programmed by manual jog point teaching, whereas cobots, like the UR5, have programming called free drive point teaching. Industry 4.0 is the next development of the Industrial Revolution. Isak Karabayevich of the University of Bihać writes, "Industrial and service robots are presently at the center of automation of production processes, and in the future it will be impossible to create intelligent automation and intelligent factory without the participation of a new generation of robots." Cobots are that new generation, and their systems are designed for ease of use and programming. Matt Lowell in IndustryWeek.com writes, "Some of the new technologies have made robots a little bit easier to use," said Jeff Bernstein, president of the Association for Advancing Automation. "You can implement them and have them up and running without a lot of time or resources put into hiring system integrators. Sometimes less floor space is required with these new robots. The promise is that these robots are safer, easier to install, and easier to program, because you don't really program them, you just move them around." This video is an example of Edwin Moroccan and Aaron Thomas programming the UR5. Edwin is using the Polyscope to enter the commands, while Aaron is tutoring him because Aaron has already completed this work before. A button on the back of the Polyscope allows for the drives to be released and for Edwin to move the robot into the position that he wants to program as a waypoint. The Polyscope allows for the robot controller to learn the position of XYZ coordinates for the point that Edwin placed. With the program completed, Edwin will move the robot arm into the start position. And once at the start position, the next command will allow for the program to run continuously in a loop. And it's that simple to program basic routines into these robot systems. Other operations such as palletization are simplified by programming wizards included in the UR5 programming. This is a palletizing program that was created by myself, Aaron, and Edwin early in the semester. The simplicity of this program was in teaching the positions of each of the corners of the pallet and the height of the pallet. And the rest, the robot system was able to calculate the moves necessary. The three-finger gripper has a variety of motions, including a wide grip and a close grip and a scissor type of action for different manipulations. In conclusion, large and powerful industrial robots with safety cages and operator stations will continue to have their own niche in manufacturing. Cobots are changing the workplace in smaller industries and changing the way people work. We have created these machines, and we must change our thinking about the kinds of work that will sustain us into the future. Education is essential as technology continues to evolve. Thank you.